So I will talk about some of experiences we have with high performance computing or large scale computing. And we learned by doing, we have some staff that computer science background. I personally am a data science background and I don't have too much education in computer science, so I had to teach myself, which can be painful. Some say like when you have to learn a foreign language, the worst way to learn a foreign language is from a dictionary. You take a dictionary, you learn the words. But when you don't know where to even to start, then you do a lot of errors. So I will talk a bit about my experience. I'll show you some coding I'm doing now. But I'm a director now, so I do less and less work, and these guys don't allow me anymore. I want to do some coding. Says no, Tom, listen, your code is old-fashioned. Your time is over, basically. So they kick me out. Also, I was a lot in R community coding in R, and then they said no, it's for little children. So I tried to push them a bit, but they Python, and then the most recent member of the team says also Python is a waste of time, so it's C++ now. Anyway, so I'll talk a bit about our experiences in open science. And we are based in Netherlands. We're about 20 people. I'm really blessed to have a very, very highly talented people, and we really enjoy our work. And we have our own building now, and we're relatively little, but we have about 7 now projects, from which 3 are really colossal, and so we have a lot of responsibility actually to many people. And we are 6 years old. So it went a bit faster than I expected. We also do summer schools. From about 6-7 years ago, we decided to video record the summer school in high quality. And as you can see, let me see here. We decided we used to put it on YouTube, but YouTube and all these things are beasts, and so we didn't feel like this is not the right place. So we were lucky to find in Germany there's an institute, Leibniz Information Center for Science and Technology. So it's funded by German government basically, and they really they managed to do it, and they organized like a video library. And so we decided to put our videos there. You can see there's a last summer school. So we basically record more or less all the talks from summer school. It's all in the high definition and high quality audio. And you can see the screens of staff, of people doing things. So you can see how to code. And so many of the people, they will watch these videos, and then you start coding, and then you can stop, you pause it, and then you try again and try again. So you can really learn. And you see there's no commercials, there's nothing. And also you can, these videos, they have a DOI. So it's really very different from YouTube. So no disturbances, no non-for-profit, DOI. You have to, when you submit the videos, you have to write a little abstract. What is this about and things. So it's, it's the right thing for scientists. Anyway, I don't know if Giuseppe, you put your video somewhere, or your summer school?
Yeah.
On YouTube?
The material. All right. Should start. Thanks.
So I think that's our little contribution to open source, because we do also make software and stuff, but I think our biggest contribution is this summer schools, and we have now almost 1,000 videos, I think. We also do interviews. We think it's not just like when you think about science and open source, there's a personal side. So we also do interviews. We also recognize the open source. Some people just come and they just want to use. So it's a bit, let's say, not the highest empathy, a bit self-centered. What can I get from open source? But there are champions of open source. There are people that come and they say, I want to fix this. I want to improve it so everybody else can work easier. And this we call the champions of open source. And these are the people we usually interview, and we celebrate them. For us, they are like really the center of the movement. And so these are people who started all these most basic libraries in R, in Python, Julia. And if they develop these libraries also in open source JS, like GDAL, GraphJS, Saga.js. So they develop this, and then they are champions. And then we call them, and we video record, and then we also do interviews, etc. So that was about the summer schools. And as I said, for me, open source is not just, it's not about it's free. You go, it's free. You don't have to pay, and everything you don't have to pay, it's great. But actually, I don't even think about that it's free. I think about, like, what can I do to contribute? And I think I see it like as a community. It is really a community movement. And this, everybody knows, everyone here also. It's a small world, by the way. And then if you continue to just expect to have something and you don't contribute, I think you miss the opportunity, and I think you won't get the best out of open source. So I just want to say, if you want to use open source, also consider that you will learn the most, and you will get the most of it if you also build it yourself. And this is also in our logo, connect, create, share, repeat. We are really our slogan, so we really do that. And somebody asked, what do you do with OpenGeoHub? We do connect, create, share, repeat. That's what we do. So we organize the summer school workshops, we organize groups, we believe in social intelligence. And then once we organize the group, we are very good in connecting things, and we are tidy, we engineer things, and then we create, and then we share, and then we repeat. So that's more or less in a nutshell what OpenGeoHub does. And we are blessed to, we applied for this Horizon Europe project call, and we won it. We submitted a proposal, which is basically bringing this key open source developers in geospatial, and saying, like, maybe we can do a bit better. Maybe we can do something which is primarily open source driven, and we call it Earth Monitor. It's under earthmonitor.org. And we have a lot of outputs already, and we're making data sets and software. And so it's about open data, open source software. We also look at different workflows and see how can we help with the workflows. We also do lots of discussion panels. It's really very generic project, Earth Monitor. We discuss, for example, is Google Earth Engine, is it a good idea, bad idea? Should everybody just use Google Earth Engine? That looks like a simple solution. You don't need to worry about anything. You just go there. It's all data is there. And nominal is free. There's no bills. So that's the things we kind of discuss, and we try to do it. I also learned now. As I was younger, I was more like a, bit rebellion, hot blood. Now as I get older, I'm more like, hey, come on. Maybe we should change a bit rhetorics. Maybe we should talk more kind with each other, and maybe you should accept that there's a different side of the story, and every coin has two sides, So this is the project in a nutshell. So we have 3 core work packages, the 3, 4, and 5. The work package 3 is like building blocks, so software and backend and front-end solutions. And then work package 4 and 5, 4, 5, and 6. 4 is the point data, so how to organize the training data. And then the 5 and 6 applications in European and global use cases. So that's kind of the project in a nutshell. And we are, I say always, we are easy to follow. So this table, basically, it's kind of a dashboard of a project. So if you want to see the data we produce, there's another community, Earth Monitor. Then we have also GitHub, Earth Monitor. We have an app earthmonitor.org, where you can see best of the best data sets and publications. And we are building also Knowledge Hub. Yes, we also have all the scientific publications automatically listed, harvested. So that's the dashboard of the project. We also write little blog post, currently the Medium, but we will switch to Ghost, also open source, by the way. I don't know if you heard of Ghost. We just tested it, so it takes a bit of time, but we will get away from Medium also. Eventually, you want to get away from all these things, whether it's American, Chinese, or whatever, but just get out of it. So we write these blogs, and one of the things we wrote last year, we had at URAC, a very successful conference back-to-back with EuroGeo. And then after that, we write these little reports. So we write, like after, with a group, we write jointly, but human readable, not something like 20 pages, just like 3 pages, the key takeaways. So we put only 12 takeaways. One of the takeaways, number 6, we discovered that today, this Earth observation data, there's many now companies, they have a copy of the data. Amazon has a copy, Cloudflare has a copy in Europe, Google has a copy. So they have a copy of Sentinel-Landsat, petabytes of data. Then they provide you services. And then you say, this great, so open Earth, open data. It's very easy. You just go and use the data. And the data is totally unusable because usability level requires that you have to remove the clouds, you have to fill in things until you have something consistent and analysis ready. And analysis ready, there's lots of discussion about it, but I mean, analysis ready to do, for example, predictive mapping, to do time series analysis, to do some modeling in space-time. Until you want to do that, you need to have it complete consistent. So you have to do all this gap filling, removal of clouds, aggregation. You have to bring everything, harmonize everything. So there's quite a lot of steps. And so what these companies do, they will take that copy and then they provide it. You can now come. It's so easy now. Before you would think like, how I'm going to work with this big data. And now it's so easy. You just you log in and they say, look, you have a coding environment like in Google Earth Engine, and off you go. You can make magic. But the problem is we discovered that everybody needs to do that pre-processing and gap filling and things, everybody. So these companies generate a passive income by having people doing the same thing over and over and then pay over and over. And the question is whether that's ethical, because this costs a lot of electricity. These computing centers now with this enormous data, they have enormous also electricity consumption. And you have all this group doing exactly the same thing. And it's a very good business model. It creates a passive income. Imagine if you have 100 people and they have to do all of them have to do the same thing, but now they all paid 100 times. And but they don't know. You don't know that your colleague is doing the same thing. There's so many people in the world and they're just doing the same thing. And as a business model, it's great. But the question is it ethical? So that's the things we also discuss. And also question, I ask you, how do you feel about it? Does that make sense? Is it ethical? And how do we change that? How do we get out of that? Because something that nominally was released by European Space Agency as open data, it finished being something that you have to pay a lot to get it to use. So definitely it's not for free. It is kind of open, but you have to go into that infrastructure. Most of these infrastructures, they require that you open accounts where they charge you monthly, and that where you have to cancellation policies 1 year and stuff. So it's a bit also becomes a bit of a pyramid scheme, and I don't know. So anyway, so that's the type we discuss, and there's more and more Earth observation data. There's so many projects now coming up, hyperspectral. There's also private companies making satellite images. Planet is now going for 1-day multispectral. They would like to put so many these CubeSats. They want to put so many CubeSats that they can have a daily revisit. Then we have also this beyond optical sensing. We have radar So there's it's the number of data is exploding. So we have to think about this issue. How is this going to work? And what's the really good model where, okay, some business, they have to make profit because otherwise business won't survive. So they have to also survive. But the question is how to organize it so it doesn't feel unethical. It doesn't feel silly that, we are paying, everybody paying Amazon to do the same things. Also, there is this thing in Earth Monitor, kind of one of the leitmotif is exactly this figure, former Twitter, now it's called something. Former Twitter, I was a big enthusiast of Twitter when I started, I don't know, 8-9 years ago. I was like, oh my God, this whole world is here. I can, you connect to the people and you don't have to go to conference anymore. You just people post from conferences and you're like on a conference. So for science, it was amazing, the potential to connect and to discuss. And it's very efficient because it forces you to do short, you do very short things. And so, but it was one moment, this guy bought it and then, I grew up in communism, so there's also different perspective on things when you come from communism. And one moment I wanted to post something and I see that he was blocking Mastodon and things. And then I realized this guy is blocking me on my own account, which is supposed to be like public place to discuss things. And then I read a bit about it, and turns out that all the content you write also on Twitter. So if you write something intelligent, some text, or make a figure, that the content is actually, it's a property of Twitter. When you post it there's a little line in the contract that they put the lawyers that, it is once it's on you're on their server, they control that content. So you post things on Twitter and Elon Musk can wake up one day and I say, I don't let you access your own thing anymore. And for me, there was a moment, as I said, coming from ex-communist country. For me, no. So I had 5,000 followers and I deleted my account. It took me a long time actually to delete. They require that you cool down for, I think, a couple of days before you can download all the data and things. Also, it's totally untrue. They could make a download possible in seconds. And then I switched to Mastodon. And I looked at this Mastodon. I didn't know about Mastodon. So this guy here, upset on the picture, a very cool picture actually. Eugen Rochko, he was a student, and he made this. He said, "I make it open source. I don't believe in this." So he made a open source Twitter basically. And then I heard about this term Fediverse. So who has a Mastodon account? Let me see. Mastodon. Okay, so it looks like you sold that table there. It's good. So let me see. Let me see Mastodon. By the way, so there's many Mastodon instances. So this is our OpenGeoHub. OpenGeoHub one. Actually, it's a better than the Twitter. You have the only thing I don't like, you cannot put code. So, and I read about it, why they don't support Markdown or something, and they have a reason. They say you want to Markdown, you go to some GitLab or something. You want to just discuss things, you come here. So that's the only thing I miss. But you have you can see this is the live feeds from this server. So the Fostodon server. And so I can see all the people that are on Fostodon. And this one is the all. So that's the whole Fediverse. So this goes very fast. So things are just jumping up. There's no commercials, right? Nobody controls it. You write the 500 characters. At the moment, the things you write in when you write things in Twitter, for me, I cannot do anything on Twitter. You cannot write a sentence. I don't know if they shorten something. Like, I mean, you have to really start paying for Twitter, which is okay. I mean, to pay for Twitter is fine. I support it. But just have in mind that there is also Mastodon, and you can connect with people and has all the functionality. It's open source. You can download at any time all the content. You own the content. You set the license. you can have your own Mastodon installation. You can customize it. You can add stuff. You just have to follow some minimum principles. And it is a very low cost, actually. It just takes about people to think how to connect, and you need some basic software, and then you create it. And why is it low cost? Because if you have now I don't know, Mastodon is probably on thousands of servers, but everybody has their own server, and you pay your own server. So then the costs are distributed and becomes low cost. And that's another idea of the Fediverse, to join forces. So anyway, I ask you now, consider it, test it, use it and connect, because after this, for example, this Geo Hackathon, you can still connect with me. And if you post to me on Mastodon, then I will respond. And if you ask a question about open source, you ask it publicly on Mastodon, then I don't just help you, I help the whole community. And that's, for me, it's priority. When you write me an email, I said, hey, Tom, I'm stuck with this, how do I compute with this? I help you for what? Like, my time is limited. What do you think? I wait whole day till you send me an email, I help you? Then, we make a contract and help you or something. But when you say, hey, Tom, I'm stuck with this, and you post it on asking the Mastodon so the whole world sees it, then I say, yeah, you do it like this. Because now, anybody in the world can say, okay. And then if somebody asks me the same question, I say, here's the link, it's explained here. Okay, so this was, we started in 2022. 2020, sorry, we had a couple of projects, and we started doing global modeling 250 meter, but time series data. And this is Leandro. Oh, by the way, Leandro and my colleagues, Leandro and Yufong, they will be also talking this week, so they will go more into detail. I'm just giving more like a, picture from above and a bit of history and stories. So we said, let's do this. Well, we have a vegetation index, and then we had FAPAR, but we said, let's do the time series analysis. Very interesting. We wanted to see, possibly detect land degradation pixels in the world. And so we said, okay, let's do that. And at the moment we said, let's get the data from Google Earth Engine. We were also considering just doing everything Google Earth Engine, right? It's possible. And Leandro knows how to program in Google Earth Engine. But we said, yeah, some things we want to do our own way and our own packages. And so let's download, we created the aggregates, bi-monthly aggregates, and then we downloaded it. And then we processed it, and it was all done in Python. And then you get, you start with, that's why I said the analysis ready. So you have, for example, 1 month, you can see there's many pixels are missing because of, if you go winter months, northern hemisphere, you have like snow and clouds and things. So with this thing, you cannot do consistent analysis. So we had to gap fill all that. So you had to go in this workflow. You see, we had this gap filling, and we had to create a land mask. So we cannot gap fill everything. We don't have to we have to know what are we gap filling, how we gap filling. And then once you gap fill, then you can do trend analysis. And so we ran that, and then this was the whole parallels, you see, properly optimized. So do you see any core having vacation? So by the way, at OpenGeoHub, this is also my stuff like this. They're all just non-stop green bars. No, it's people and not robots. And so then you get this. It's kind of like Earth breathing, right? It's like a heartbeat or something of Earth. It's very cool. And this one image is, so we created all this mosaics, whole world. And one image is 160,000 by 65,000 images. And that time, well, I can show you that also. We put it on now a main platform called Open Land Map. And so I'll open now here. Let's go to trend thing. So here's a map. If you stack bi-monthly data for 25 years, And then for every pixel, you fit a regression model after deseasonalization. So you take the seasons out, and then you fit a trend model. So Leandro went and fit, so there's like billions of models. For every pixel you fit for time series data, every pixel is independent. And then I said, okay, you have all these parameters from the model. And of course, one of the parameters is the slope. So I said, and this is just a beta, so just the slope. And so we can see Europe, you know, it looks greenish. But we zoom in into Vienna somewhere. Let's see. So here's Vienna. Now I start seeing there's some, so the pinkish color is the negative slope, and the greenish color is the positive slope. But they're very gentle. We stretch it a bit, so we emphasize, so very gentle slopes. But nevertheless, for 25 years, we can see there's something happening here. So this is for the FAPAR vegetation index. It's all kind of highly correlated, but basically it's the primary productivity photosynthesis. So we can see here, for example, there's something pinkish. And now difficult to see, there's some factory or something established here. Maybe some new part of the city. I will have to also maybe switch to satellite image. But it looks like they build up something, and that construction, urbanization of that area of that part of Vienna basically resulted in the effect was that it got less green. So the vegetation is down. And so you can look, that's something I'm looking here. I don't know, maybe I can go in somewhere in Luxembourg here. Is Luxembourg on the map? It's very small. Where? Here, I found it. So Luxembourg looks okay. But by the way, this is a 250-meter resolution, so really big pixels. And but also you can see that, for example, when I zoom out even more, you can see that, for example, China is all green, India. And it's a very known phenomenon of China and India increasing the agricultural productivity and basically taking a lot of land for production and making it all much greener. But then if you go to, unfortunately, so you can see the jungle, it has no color like white. It means slope is close to zero, no changes. And then you see these things changing like here. You can see the things are changing. And we can put, for example, this is the land cover. This is the only land cover product, the 30-meter space-time going from 1985, sorry. So you can see how things changed in the time. And so you see this used to be all forest and now disappears. So it's been converted mainly to pastures and soy plantations. And because Brazil wants to grow its economy and they have this native forest, but they say we don't have any use of that. And then they go and make, and so I can see, for example, let's zoom in somewhere now, like this one. So you see this one is a bit pinkish. So let's see what happened here. So it used to be a forest and then it got slowly converted and now it's probably a pasture land. And you can see effect of that but some pixels next to it, like here, it's also pasture land, but looks like it didn't affect. So it's complex, it's not easy to this, I think, today environment, because you have a climate, environment, human, biodiversity, living being. It's a very complex interaction. We pretend we know about this stuff, but actually there's a lot of still complexities we need to figure out. So that was this thing we did. And then after that, we went, okay, we published it as a paper. You can read about it. It's a lot of, this paper was a lot of work, lots of computing, and really proud of everyone. And we made all the data available. The data was 1.4 terabyte, even though it's 250 meter, but because you have time series, 1.4 terabyte. Rolf made a software to be able to submit that to Zenodo. Because how do you upload 1.4 terabyte to Zenodo? Zenodo is 50 gigabyte buckets. You only need like a 50 people opening new buckets and uploading and checking. And Zenodo is also now suffering. They have too many people. They just made it like, open. And it's really suffering, lots of broken uploads. So we had to make a software. Rolf made a software called Zen to upload it. And then we managed to get 1.4 terabyte. And it's in how many buckets? Like 100 something buckets. And he made a Python software called Zen, very cool name, Zen, library for Zenodo. And it actually has the code to distribute the files and to generate meta information, the text you see. And so we did it. So that was the 2020-21. And then we say, okay, now we got a new project, and now no more Modis, we switch to Landsat. It's a gentle switch from Modis to Landsat. The size is about 100 times more, I think. So we got this big project, and we were very stubborn, and we organized ourselves to get a copy of the whole Landsat, and it was a 6 months operation. Now I will do it in 1 month, because now we know how to do it, but at that stage we had to test everything, copy, how do you copy in parallel, how do you do this? And so we got that copy, and so we have 26 years. This is the Maryland, it's called Landsat ART version 2. And now we said, okay, now we have to organize that, where do we put it? And then we had all this software like Slurm and Docker, and we were running, of course, Ubuntu. And now we said, okay, what do we use as a file service? And we looked at Ceph, some Garage, Proxmox, plus Ceph, GlusterFS, Seaweed. This took also about 4 months. Incredible, just a simple thing like where we're going to store this, and discussions, calling people, help us. Then we notice, for example, Surf uses Ceph, and Leandro again starts testing it. And then he says, oh, no, it's like you need to customize it. It's so much work. It will take us months. And then he finds this guy, Chris Lu, one person. Look at his GitHub life. Well, do you see any weekends? I don't. But yeah, it's very greenish. I mean, I have also some, I do commits now. I'm trying to do more and more GitHub, but nothing like this. So we were thinking like, is this a real person? I mean, the pattern is too overwhelming. Anyway, so he made this Seaweed, and he has a pattern if you want to help to make it better. And Leandro tested it; it works, and it's scalable, so we can just keep on adding more data. And so that worked. And then we organize all these nodes, and so we have a storage and a computing servers. We have now 15 computing servers. They all are upgraded now to 1 terabyte RAM. So we switched to that, and so, okay, that works. But we cannot process Landsat. It's not possible, because in the bottleneck we discovered it will take just so much time just to read and write. It would take, Leandro's first estimate was, I think, 4 months to process on our own infrastructure. And we said, okay, that's work. And then Davide Consoli, a PhD in electrical engineering, never worked with satellite images, doesn't know anything about environmental sciences. Last papers he publishes about some math, some signal theory compression, I don't know. So he came to work with us. I didn't know what job to give him. I told Leandro, yeah, there's this guy, he looks really smart, but I don't know what to give him to do. So, but he started looking at stuff, and he's a very good engineer also. And he says, you guys, you need to switch to InfiniBand. So, okay. So we switched to InfiniBand, we connected everything. So now we have a storage, 3 petabyte storage. We put InfiniBand. Nominal, it can go up to 40 gigabytes per second. And bingo, started doing some testing. We're getting 30 gigabytes per second. We started running analysis. So if you take one server, we put 1 terabyte RAM. RAM is the best to do anything, right? So if you can, you put everything in RAM. So we said, okay, you take 30-kilometer tiles, 30 by 30 kilometer, and then you read 504 images, whole time series from 1997, and then you do everything in the RAM, and then you finish and you close. And this is time we have now, so 55 seconds to read about 8 billion pixels, and to write it's about the same time. And with this algorithm, we managed to process, and with this setup, we managed to process the whole Landsat. We created a new graph filling methods. We innovated. We changed some standard graph filling. We read in literature. We did a really also extensive, a lot of comparison testing, cross-validation. And then now we are recomputing again Landsat. Now we're doing fusion Landsat modis, because we discovered that it's better to, if you just use Landsat, you have some periods where you have almost no pixels. This is the usual Landsat, this one on the right. So you can have many areas in the world, you have basically nothing. It's just all clouds. And so we are running in this thing to process. Leandro, what's the estimate now to do the gap filling? 6 days, whole world. And we can still reduce it. Oh, by the way, now all the code is C++. Also, Python we only do for testing. So all this programming language just testing. Production always just C++. And so we call that the HPC on steroids. So InfiniBand, C++, and every detail optimize, everything parallelize. And Leandro went and said, okay, now I'm going to use this to do mapping. So this paper was about processing Landsat, and this one is now we do machine learning. And Leandro he got like about 8 million training points. Thanks also to our colleagues from Brazil, from LAPIG. And then we reduced a bit number of points, and we do the space-time machine learning. So we mapped grasslands, 2 types of grasslands for the planet annual. And this took also about maybe 1 week. 1 week computing or something. Now the bottleneck is GDAL, generating mosaics and things. This is a bit bottleneck. And we create this, what we call 4C ARCO. It sounds like R2D2, something from Star Wars. 4C ARCO, complete, consistent, current, correct, and analysis ready, cloud optimized. So you can put the whole world. This is example of Landsat product. So it's again, like with the MODIS, it's a whole world, one image. And it's consistent, so it has no clouds. All the values are the best estimate of the value, even if they're clouds or not. No artifacts. Well, there's some artifacts still in the northern hemisphere, but less and less artifacts. And it's just a one image, and the image is huge. I mean, it's 1.4 million by 560. But then you have the magic of Cox, and now also with the ZAR. So you can just drag and drop it in QGIS. You don't have to download 134 gigabyte, but you just take the URL, you drop it in QGIS, and you can access all these images. And so here's a one. Here's a just example. So this is a COGS from Open Land Map. You can see this is the land cover. It's also like 20 gigabyte, but it has all the pyramids and things, and I can talk on the Teams. And now it's a bit slower because there is Teams in the back, but if I zoom in, I will get a 30-meter resolution images. So we created also this plugin for OpenEarth Monitor. We created a plugin. You can pick up global or European data. It will show you all these collections, and then you can just pick up and it will put it with the legend. So it's it's even faster. So you can take digital elevation model, I don't know. So you can just put it and you can just drop it in the QGIS. But it's not just it's like WebGIS. I mean, this is literally data. So if you want to do analysis, as soon like once you zoom in, and I said, now I want to do analysis only on this, you're ready to go. Okay. So that was the thing on steroids. Now we're doing the MODIS Landsat merger, so data fusion, and we are going to produce about 400 to 500 terabytes of this data, which is not what Google or Amazon or Cloudflare give you, but this is the data that you just go. There's no like now you have to spend 2 months to figure out how to remove stuff and make it analysis ready. So this is 4C ARCO. And now we are stuck because we don't know where to host it. And funnily enough, I go to European Commission, I go to European Space Agency, we can make this data, we're not commercial, we want to give this data to people, and we cannot pay for this because it's too much for us. 1 petabyte to host 1 petabyte data. We don't have the infrastructure. And we still nothing. Nobody helps us, nothing's happening. They always, oh, that's great, you guys are doing great work, bye-bye. So we are still working on that. We have to see where to put it and what to do with it. But yeah, and that's coming in October. We'll have a conference here in Vienna, and please come if you're interested. If you're interested in these things, come in Vienna, same place here in October, first week of October. We have a conference, 1 week conference, 3 days open conference, 2 days hackathons, code development sessions. And we'll talk about all this data solutions, geodata solution, and there's a GeoZar coming, and David thinks actually we should switch to ZAR for some reason, or we should have a 1 copy ZAR, 1 copy COG, because both are optimized for different things. So anyway, so that's what's happening. We also make the software scikit-map, so scikit-learn for mapping, SITS for space-time analysis. And we also look at the back-end and front-end. At the moment, a lot of interest is in this combining COGS through Rio Tyler with a fast API in Python, so people can do things very quickly. Just the last thing I want to show you, I do still code, so here's a data set. It's a cropland map of the world, and the guys in Maryland made it, Peter Potapov. They publish a paper and they say, here's the data. It's not cloud optimized or anything, and it's like tiles. And you only have the 2003, 2007 to 2019, so every 4 years. So, and then I make a code using the Terra package. Anybody uses Terra package? Terra? Yes, okay. So Robert Hymans made this amazing package, Terra. He first made the raster package, and then he reprogrammed lots of stuff in C++ and redesigned completely. So he made this, and so here's my little server. I use this Remina here. I use the Remina to connect. This is on the machine in my office. It has the server has 80 threads, and it has 1 terabyte RAM, so I can crunch this data, no problem. But now I need how I'm going to. The mission is I have to interpolate all the years, so I create 23 years, and then I want to create COGS. And I started doing the coding, so I define this input years, output years, so I define that. Then I create a tiling system. For tiling system, I just basically resample to 1 degree cell, so 100 by 100 kilometer. And then I create this one. This is you see the code in Terra, it's very compact. You would just say, these are the time series of data I have. And then this is on 1 degree, so 100 by 100 kilometers. Then I say sum it up, and I remove. And once it's sum it up, I can see exactly in the world for all 20 years, I can see where the croplands and different density, right? Because it's a sum of the occurrence. And then I create a polygon map that I just want to visualize. And then I make a little function. And in this function, I will, with this thing, I will tile. So it's to the Terra crop. So I run for 14,000 tiles. I create a function that will run in a loop. So I create a little function. I say, give me this tile. So if I load it, so I will just read that from that big TIFF. I will just read that little tile, and then I can convert that to in R. You need eventually, if you do some interpolation, you need it as a data frame or data table. And then here I do the approximate function, which will do interpolation. So the interpolate through time, and I can do different functions, splines, linear interpolation. Now I use just a linear interpolation, and I make that function, and then I convert it back to raster once I finish interpolation, and then I write each year, I write it into a GeoTIFF. And as I write it into GeoTIFF, I get, so here's the output I get for each year, I get these tiles. So it's almost, let me see, 11,000 tiles. So I create these new tiles by interpolating in space and time, and I can run that in parallel here. So I make a function, I run it in parallel. It works, the most of Terra code is in C++, so it's as fast as possible. And because I have 1 terabyte RAM, I can use 70 threads. That's the maximum. I could have made a smaller tiles, then I can use 80 threads, but I didn't want to play. If you make a too small tiles, then you have lots of single pixel tiles and gets a bit complicated. And then I build the mosaics. And so the whole code is about 60 lines with the Terra package. And I run it, and in 12 hours, I create all the output just on this one server. I don't have time. I would have done a demo. And then I get outputs. I have a complete consistent. So now I have it. I can zoom in, and you can see this is the 1 kilometer. I have the 1 kilometer. I have the 250 meter. I have the 100 meter, and I can zoom in a bit more. So this is the 100 meter, and you can see this is the regional 30 meter. So I have it also at multiple resolution. And now it's analysis ready. I can do now lots of modeling. I can really use the data. So I have a complete consistent time series, and I can reproduce it in 24 hours, basically, or less. So I just wanted to show you like a demo that I do still myself code because I understand the data, and I'm quite okay in R now. And with the Terra package, it's really magical how few lines of code. It's very intuitive coding with rasters. And so you can do a lot. And I see people, you use Terra, you know it. Stars also aims at being very similar, but Stars, I think lots of stuff is in R still programmed. So it will be a bit slower, some things. So Terra has many things, like especially some computing, like aggregating, time series analysis, things like that will be faster. And with this thing, I close. I don't know if there's questions.
Yes, thank you very much, Tom. Interesting talk. Yeah, I would open the floor for discussion. So yeah, let's use some time to pose questions, and then we can move to the tutorial. So please go ahead.
Raymond.
I'll just go first.
The Open Land Map application you showed, it has the API, and for vector tiles, you use PG tiles. And is that application open source?
So Open Land Map, we tried several things, and at the end we went for simplicity. Something that you can just keep on extending, keep on adding. And so in the center, it's this is the front end, right? But in the center for the data, to use the data, there is the stack Open Land Map. So you can see all the layers. And now we are writing tutorials. We're writing tutorials, and they look something like this. So you can go to tutorials, and you can see all the layers that you can find. So they're also listed like this, so you can very quickly load it. But there is a package in, for example, there's in Python package in R package in R is called R stack, and so you will just go and say read stack, and you get all the layers, and then you can search. I want the land cover layers, and then you find the land cover layers. So there's 75 entries, and then you can do, for example, point overlay. You can do clipping. You can do some analysis on the client side. So it replaces the API basically.
Okay. And this is all open. There is no authentication required.
There's no authentication required. Not at the moment, no. We would like to keep it like that, but we cannot keep on paying. Now we pay Wasabi, you know, but we cannot keep on paying that. So we're looking if the European Space Agency or Copernicus Data Space Ecosystem will organize something so people can access. But there is some issue, this thing with authentication. It's also world of internet is changing. There's more and more security. They want to know who is using what, when, and, you know, so, but we also make it on the front end. We make it visible for people to, so we are kind of like what all the other organizations do, but we make it transparent. You can see actually who's downloading which layers. So it takes a bit of time till it generates, but every time I click on it, it will look at the statistics and say, these are the most access layers, most downloads, most views.
That's only for people who created an account and logged in.
No, it's all public. We don't have any
Okay.
user. We went for really simplicity. And for simplicity, we had to do, we have to give up on lots of administration and, this is not coming.
Yeah, because in the PPT, I think I saw Auto, which is like the authentication provider. So I thought everything was behind the authentication.
No, the key is the stack. Anyway, thank you so much. I stay here whole week. You can still talk with me. And Leandro and Yufeng will also show a lot of data. So.
Thank you, Tom, very much.